Hello, Algebra 1 students. So today in this video tutorial, we're going to talk about linear inequalities. This is 7-5 if you're keeping up in your portfolio. And we're going to do this by objective. So we're going to go over their first objective today. And this is to graph linear inequalities. We're just going to learn how to graph them. What is a linear inequality? A linear inequality describes a region of the coordinate plane that has a boundary line. What are solutions of that inequality? Solutions of that inequality are the coordinates of the points that make the inequality true. So you're going to see what this looks like here in a second. So example 1, graphing an inequality. We're going to graph y is less than 2x plus 3. The first thing we have to do when we're graphing this inequality on the coordinate plane is to graph the boundary line. And let's talk a little bit about that for a minute. The boundary line is going to look like this if this were an equation. So the line that we would write for y equals 2x plus 3, but with a few distinct differences. If your sign is less than or equal to, less than or greater than, it's going to be a dashed line because it doesn't include the points on that line. If it's less than or equal to or greater than or equal to, it's going to be a solid line. So just remember that when we're going for it. And you can see that this is going to be a dashed line right here. Okay? So let's graph this like this were a line. This is y equals mx plus b. We're going to start with 3 on our coordinate plane. We're going to go up 2 and over 1 because our slope is 2 over 1 and draw another point. And like I said, we know this is going to be a dashed line here. So it's going to look something like this. Okay? So that's our boundary line. That's what it looks like. But we're not quite finished yet. We have one more step. We need to figure out which side of our boundary line is going to be our shaded region, which side of our inequality is true. The easiest way to do that is to pick a point anywhere on this coordinate plane, plug it back into your original inequality, and check to see if it's true. I always like to choose the origin. So we're going to check 0, 0, and I just think it's easy to check the origin. So again, it's y is less than 2x plus 3. We're going to replace y with 0 and x with 0. 0 is less than 2 times 0 is 0. 0 plus 3 is 3. Is 0 less than 3? Yes, this is true. So you know the region or the side of your boundary line that includes your origin is going to be shaded. So it's going to look like that when it's all said and done. And this is telling us that anywhere in this shaded region, not our boundary line because it's dashed and it doesn't include, but anywhere in this shaded region, any point, we could plug back into our equation and it would come out true, anywhere in that region. As you can see, this is different from a system of linear equations. It's not just one point. It's going to be infinite in many points, which means you're going to have to draw it out. Okay, let's move on to our last example for this one. Rewriting to graph an inequality. So this looks more like standard form when we're talking about linear equations, but we're going to rewrite this to look like y equals mx plus b. Okay? And there might be a few rules about inequalities that you might have to remember from last semester. So let's try and rewrite this. We're going to subtract 3x from both sides because we're going to try and get the term with y by itself. So we're left with negative 5y less than or equal to negative 3x plus 10. That was a bad drawing, I'm sorry. We haven't changed our inequality sign, we just dropped it down. Now to get y by itself, we're going to divide by negative 5. And if you remember from last semester when dealing with inequalities, you always flip your sign if you multiply or divide by a negative number when you're dealing with inequalities. So that's something really important to remember. So we're going to go ahead and flip our sign. Our negative 5's canceled out. Negative 3x divided by negative 5. Well, the negatives will cancel out, and we can just rewrite that as 3 over 5x. 10 divided by negative 5 is negative 2. Okay? So now we can graph this. We know this is going to be a solid boundary line because it's equal to. Okay? So negative 2 is our y-intercept. Up 3 over 5, so 1, 2, 3, 1, 2, 3, 4, 5. Again, 1, 2, 3, 1, 2, 3, 4, 5. Okay. And a solid line. Sorry, that was a little crooked. All right, so again, we're almost done. We've drawn our boundary line. We have to figure out which side of our inequality is true. And again, I'm just going to check the origin, or 0, 0. So 3 times 0 minus 5 times 0 is less than or equal to 10. I just plug the origin coordinates back into the original equation. If this comes out true, you know it includes that side. If it doesn't, you know it's the opposite side. So 3 times 0 is 0. 0 minus negative 5 times 0 is 0. 0 minus 0 is 0. And 0 is less than or equal to 10. Yes, that's true. So we know that it includes this region of our boundary line. Alrighty, thank you.